Alright, so let's say we want to do a hypothesis test for a correlation. The question we're trying to answer is whether there is a non-zero correlation between two variables in the population. So are two different variables related to each other in the population? Meaning, can you predict the values of one variable from the values of that other variable in the population? As usual with hypothesis testing, we'll be basing our ideas about whether to reject the null hypothesis on values that we have in a sample. So step one in our hypothesis test is to write hypotheses. Our null hypothesis is going to be that there's no relationship between two variables in the population. So just for fun here, I'm going to use the A in the class and weed example. So if we're treating the class as a random sample of criminal justice students, we'd be saying that our null hypothesis is that there is no relationship between how often you smoke weed and how confident you are about getting an A in statistics. So our null hypothesis is that there is no relationship So no relationship between confidence in getting an A and smoking weed. That's our null hypothesis. Our alternative hypothesis then is that there is a relationship between these two variables. And if we reject our null hypothesis, we'll have evidence that will make us think, oh, maybe these two things are related in the population. So our alternative hypothesis is that there is a relationship. Another way that you could write these hypotheses would be in terms of R. So our null hypothesis is that R, or our correlation coefficient, so this number that varies from 0 to 1 and is either positive or negative, our null hypothesis is that this value is equal to 0 in the population. Our alternative hypothesis is that this value is not equal to 0 in the population. And so these are just different ways of writing these two things in terms of a correlation. So step two is the test statistic step. So as I mentioned before, in a correlation hypothesis test, your test statistic is actually that R value. So in this case, our R value describes the relationship between smoking weed and confidence in getting an A in our sample. Where we had an R value of 0.11. So, and this is sort of a dramatization of it, but we had this weak, because you saw what the actual graph looked like, but we had this weak positive relationship in our sample. So in the actual class, as scores increased here on this number of times smoking weed per month, so as you had a higher value here, we're moving along this direction, we generally had more confidence in getting an A, so moving in this direction. So we had this overall upward slope to our line. Even though there was still a lot of variation around that. So we had some people who didn't smoke a lot of weed who were still pretty confident in getting an A, and then we had some people who smoked a lot of weed and were less confident. So we had this weak positive relationship. The test statistic that we're going to use is R, so there's nothing to calculate here. So once R is calculated, which we're also not doing in this class, you have nothing new to calculate. And we're going to just treat R as the test statistic. So it's doing double duty here, right? It's describing what's going on in our sample, so it's telling us about the correlation that we have, and it's also something that we can use to tell us where our sample would fall on a sampling distribution. So our sampling distribution, as usual, is based on a world where the null hypothesis is true. So if there is no relationship between smoking weed and confidence in getting an A in the class, we would have possible R values that you could get when you take a sample. So you take a sample from a population where there's no relationship. You might just happen to get a sample of people who have, where people who smoke weed more have more confidence in getting an A and vice versa. So that's just a possible outcome you can get just by chance when you take a sample. So it's possible that even if R was really 0 in the population, you would get an R value that was something other than 0, and it could be higher or lower. Then you also have the probability of getting each one. And R distributions, or sampling distributions for R, tend to be, they're negatively skewed. They're also a family of distributions, but in general they have this sort of negative skew here. And then what you do is you plot your R value on that distribution. And the area under the curve becomes your p-value as usual. So here we had an R value of 0.11, and then our question becomes, is this R value of 0.11 so big that we have evidence that there is a relationship between these two variables in the population? Is it so big that it would be unreasonable for it to come from a population where really the relationship between these two things is 0, and the graph just looks like a blob and not any sort of line? So step 3 is to decide whether to reject the null hypothesis. And so there's a p-value that's attached to your R value based on the sampling distribution, where here there's, again, other things that go into what shape the distribution is. But as usual, we're looking at the area under the curve that is determined by your test statistic. So for R value of 0.11, our p-value comes out to 0.44. So we can interpret this as meaning that if there was no relationship between smoking weed and confidence in getting an A in this class, we would see a correlation as large or larger than 0.11, or as extreme or more extreme than 0.11, about 44% of the time just by chance. So this is a really likely result that you might get in a sample if there's no relationship between these variables in the population. So at our standard alpha level of 0.05, we fail to reject the null hypothesis, that there is no relationship between these variables. So this positive relationship that we saw in our sample isn't enough evidence for us to rule out the idea that confidence in getting an A and smoking weed are related to each other. Alright, so that's the hypothesis test. I am now going to go back into the slides one last time, talk about correlations in Stata, and then we will talk about the project as well and what will be expected for that.